Boy, oh boy, this F-16 from Skymaster is looking awesome. Video 3 starts now. Let's continue on with this beautiful F-16 1/5 scale from Skymaster rcjets. All right, so last video we made up our startup plate and we're going to get this fit and screwed into place. So to do that, we're going to hold the startup plate like that in the right spot. And we are going to drill some holes through the arch, through the startup plate, and then we'll be able to recess our screws. All right, so we got our plate all installed here. So I've installed it with 5 screws. So install these guys one at a time, and then what we do is we can take the plate out, but we're going to countersink those guys with a countersink bit, and then our screws will end up being flush with this. 3 is actually plenty, but I drilled out 2 more just so we have them, and I think that's going to be nice and strong. So our air brakes are now dry to the touch, but we're still waiting for those guys to dry before we reinstall them. So those are on hold. We're going to come around to the back end and start working on things back here. So we've got quite a few things to do. Obviously our servos back here. We've got to run our afterburner wire coming to the back. We also have to redo our mounts. Now this is pretty common in almost every aircraft where you've got aluminum mounts or the surface mounting mounted onto the wood. So what's happened here, I put a little note bolt-in tray. So there's a bolt that goes through here that pinches the vertical stab in place, but that has fallen out. So the bolt is in the tray. So what's happened was in transport, that has fallen out on its journey here to North America. But our aluminum mounting plate is also loose, so we want to make sure we tighten those up. So we've got one here and one in the front. Okay, so we're moving on to the tail section, and the manual has a decent layout here for the servo arm. So the one that it doesn't really talk about so well is the elevator arm. So these are listed as 55, and that is not correct. Those need to be 20. So if you look at the diagram, it's hard to see it on the diagram. You can make out 20, but I know it's 20 because I've got lots of experience. Skymaster basically, for this type of elevator setup, the dimension from center to center is always 20. Now the carbon arms that we use here are very good from MKS for this scenario. The first arm or the first hole on this arm is exactly 20 millimeters, so that is perfect. So that's what we're going to use for the elevators and the rudder as well. And then we've got our other layout here on the manual, which is aileron horns 30. That's going to be our slats, which is 10, and rudder horn, which is 15. So initially here, of course, the manual says it's designated for an 8911 servo. We're using the MKS 599s. So we need to check and make sure that our depth is going to be good for this first. So that's the first thing we're going to check, is we're going to pop a servo arm on there and just confirm that our depth is in fact going to work with the servo. And if not, we have to figure out spacers. Okay, so we got our servo installed here. Did have to put a little relief cut on the side where the cable comes out of the servo. So I just take my Dremel and just put just a little cut in the back of the wood, and no problem at all. So then what we do here is we take our servo arm, install it, and see if it's clearing the skin. So that is basically what we're looking for here, is to confirm our spacing. So it looks like I have to put 1 plywood spacer behind that. So let's pull this guy out and I'll show you what we're going to do. So these little plywood spacers, I cut these out with my laser tool. So these are, I don't know the thickness, but probably a 1/16. And we can install these guys on the servo. Now, the relief cut I did there is on this side right here, just my Dremel, and just do a little touch up. So it's nothing major there, but it basically cleans it all up. Now I can't get that installed. So we can't get it installed, so I've got to put it in beforehand. And now I can get the servo installed. There we go. So now we take our servo arm again, and we install that, and just check our clearance. So basically what we're looking for here is when this servo is tightened down, we want it to be as close as possible to the fuselage without touching. So we've got just a fraction of space there. close. I think once everything's tightened down, it's going to be perfect. So the reason that's important is your elevator plugs in to this area here, and there's a receiver in the elevator. I'll take you over there and I'll show you that. Okay, so here is the horizontal stab surface, or the elevator surface, and this is the metal receiver that goes inside there. So there's bearings that fit inside here, and this is the setup just like this. So as long as you're really careful, in most cases, you just have to do a cutout in this area around the receiver portion. In some cases, when you're using a funky receiver or servo arm combination and stuff, you'll have to do a cutout in the actual surface on the top and the bottom, so right where that rivet line is. Generally try and avoid doing that. So we're just going to be as careful as possible. The tighter you can get that fit, the less likely it is you have to do that cutout. Okay, in preparation to accept our servos here, we are going to screw in our big servo screws. Now these are not included with the kit. These are big pan heads with aggressive wood threads. I'm going to drill those out a little bit more, but we're going to thread these into each of those 4 holes, and we are going to treat those with CA to get ready for putting our servo in. So one of the big benefits of these MKS servo arms is you can pull the carbon arm off, and you can rotate the receiver portion and get it pretty close. So in this case, we had to add 11 points of sub trim, but now we are nice and centered on the servo itself, and that's perfect. So what we need to do is we need to add a countersink on the back side of this. So there's 3 sets of hardware here. Number 1 is the ball styles. These are going to be for the rudder, and 2 of them are for the flaperons. The angled head, or countersink head, those are for the tail section, which is what we're working on now. The button heads are for the leading edge slats, because those don't matter to have a head or not. So that's our layout on this stuff. So I'm going to take this over to the drill press and add a countersink, and it's got to be enough of a countersink so our angled head is flush with the back of the carbon. All right, and there's a shot of what you're looking for. So the back side is recessed, nice and flush. We've sanded down the servo arm, 3 bearings, washers between the arm and each bearing, and the lock nut, and that is a perfect setup. So we'll put a drop of CA on the connection between the carbon arm and the hub, and then we'll get that screwed down, and our elevator servo is good to go. Now I don't know yet if these need to be reversed or not, but we'll deal with that once we get it installed. All right, so one thing I'm going to do here beforehand is I'm going to make up my servo leads for the elevator servos, get them installed, get them shrink wrapped, and we've got the lead zip tied. This is just going to be so much easier outside of the plane, and because I am running excessive lengths of line all the way to the front of the plane, not a big deal if we're 6 inches too long here. So we've got 2 7-foot leads done up. We're going to get our ends done on these guys and get them installed on the servo. All right, so we got our left servo installed. That's done. Working on the right servo right now. Now just spacing in the back end here, you have to be prepared to do different things to make the spacing work. So on this side, as I've talked about, we used our plywood spacer. On the other side, I just got the servo installed. And on this side, the plywood spacer was too much, so I ended up using washers. So there's 4 washers underneath that servo, and that was the perfect amount. So this servo arm is as close as it can be to the fuselage. So getting closer here, now we need to test fit our surface and check and make sure that it fits. Then also with the surfaces, this is basically the minimum that I'm always looking for. So you do a big cutout there that allows free movement for the entire servo arm and not touching the top and the bottom surface. That is the goal right there. So next step on the elevators is we get our receiver portion installed. So I drilled out our screw holes a little bit and we've installed our receiver portions. Now that is not the final step here. There's a lot more to do with these metal inserts, but first thing we need to do is check the fit. So on the F-16, the keyhole locks are located, just get this started here, right back in this area. So you just take like a screwdriver, push it in, go. So it'll lock in place. You always want to pull on your surfaces. So pull out away from the aircraft to make sure that they're locked, which they are. And so now we can check and make sure that our travel is sufficient, which it is. Beautiful. So you do have some mechanical limits here because at this point the servo is straight up and down, and what's happening is it's all the way back in that receiver portion, the metal portion. And if you go the other direction, same thing. So at that location, the servo arm straight up and down, it's all the way back in the receiver portion. So that is the absolute max travel of each of these surfaces. Okay, so now we've confirmed that those fit and they fit good. So we're going to take these guys off. So to take them off, it's exactly the opposite. We push the little tab in and they just slide out. And when you're actually putting these together for the first time at the field, it's really helpful to put just some BVM thin lube on here, some really light lubricant. And that just makes it slide in and out of the bearings. These are our bearings in here to receive the shaft. All right, so this next step is quite important on any Skymaster setup like this, whether it's the F-18, this F-16, any of their tail sections that use this setup. This is extremely important. So if you just screw these guys in place, there's some play in here in the system. Okay, so these aren't 100% solid. Okay, so if we were just to screw those in, the screws are actually taking all of the force of the servo and the whole system. Okay, so what we want to do is we want to create a joint between this and the surface. So the way you do that is you coat this with lubricant. So we're going to use silicone lube in this case. I'll show you guys all the steps in this. So we're going to coat this thing in silicone lube. I'm going to grab a Q-tip, or if you prefer to call it a cotton swab. Put some silicone lube on the plastic. And then we'll take this. We are going to coat this entire thing with silicone lube. Now the point of doing this is to create a separation barrier. You don't want to glue this piece in permanently because down the road after a certain number of flights, you want to be able to remove this piece and switch it if ever needed. So that's why we're putting the lubricant on here. You'll see in a second. Now what we're going to do is we're going to take high sol and we are going to install the high sol all along here. So we don't need any on the face. I just lubricated the face just so we would keep our separation there. So we just want to install it in the channel. It won't take very much at all. If we can, we're going to put a thin amount on here. So that silicone lube is acting as a bond breaker. So that's what we want to do. Now we're going to install this in the horizontal stab. And when I do that, now that high sol is taking up our gaps in between the receiver portion and the aluminum piece. Now I've already put some thin CA in those holes to pre-treat them, but we're going to put a drop on the servo or the screw and install the screw. And that's going to make it lock it in place. You can get it out with it'll take a little bit of a pop to get it out, but this is the best way to mount these things. I don't think it covers it in this F-16 manual, but it is covered, I believe, in their F-18 manual. There we go. That is how you treat these receiver mounts for the actuating system on horizontal stab for Skymaster. So if you don't do this, you're going to find that this is going to prematurely wear. Your screws will probably loosen up, and this is basically the only way to do it successfully. Now you could just high sol that in place The problem is this now becomes permanent. So if you ever need to change this, getting it out is going to be basically impossible. So that's why we do it the way I showed you. Okay, so both of our elevators, horizontal stabs are complete. As far as the receiver portion goes, now it's time to focus on the cover plate. All right, so cover plate. So first thing we need to do is take our servo arm off. And we want to make sure before we take that off that we're centered. And reason being so that when we put it back on, we can get it in the same spot. Okay, so that comes off. And now what we want to do is we want to take our cover plate and we need to mark out our center of our spline on our servo. So what I do here is line it up like this, take my Sharpie, my fine line Sharpie, mark the center of the shaft, come to this side, get it lined up, mark the center. Now we've got the center of our servo arm. So essentially what we need to do here is we need to make a hole that's bigger than the largest portion of the brass on the servo arm. So it's going to be a reasonable size hole. Essentially, if you look at the servo here, the silver perimeter around the servo arm mounting right there, that's kind of the size that we want it to be. So I'm just going to take my step drill and we're going to drill this guy out and check and make sure that we're happy with that. Ultimately, what's important is that when we put this cover plate on, this servo needs to be able to fit in there and move properly. All right, so this is what you're looking for. Now these covers don't fit. I guess in my case, they didn't fit right away. They usually don't. You have to do some sanding around the perimeter. So you just spend some time sanding and get them fit so they fit absolutely flush. It's important that they're flush because our servo arm sits flush to the fuselage, so these can't stick out at all. So this is exactly what we're after. Our servo arm, I've already tried it. Our servo arm fits perfectly in there and it's exactly what we're after. So what we'll do now is we'll drill 4 holes in here and we're going to add some countersinks so we can use our small little screws, and we'll do those in the corner. And then after this is done, we can get our servo arm back installed. All right, and there's our finished result. We've got our servo arm installed, our cover plate installed. When we do our finishing, our weathering on this aircraft, we'll touch up these areas, but this one side here is done. Now we got to do the other side. Okay, so our elevators are installed and they are complete. So we have a ridiculous amount of movement available, which is absolutely awesome. So the manual calls for 100 millimeters in each direction, and I think down is probably a little bit more, but up elevator is a ton more, I believe. So anyways, we've maxed that out. That's awesome. That is wonderful. Super cool. Okay, so we have reinstalled our air brakes here. Now those are a little bit of a chore to get installed. So what happens with the air brakes is these little linkage covers, I guess maybe is what you'd call them. They are a little bit of a pain. I actually had to end up redoing both of the inner ones on each side because they weren't quite working properly. So when I was closing them, this one would stick up a little bit and I wasn't closing all the way. So I ended up using a little piece of brass tubing, redoing the linkage, bending the linkage. Anyways, those are done now and they are installed and they're gonna work perfect. So that's done. Didn't really video any part of that. This took quite a few hours actually getting those redone properly. The challenge with them is you have to do everything out of the plane in order to have good access. So you can kind of access stuff here, but in order to actually adjust anything, you need to take the air brake out. So we ended up putting the air brake in and out about 4 or 5 times per side. So that was definitely a chore. Working on the rudder setup now. So the rudder setup, the manual is pretty good. It tells you exactly the distance from here to here. And what I've done is I have measured out the center of our channel, our receiver channel on our rudder surface. And that channel is this guy right here. Now this is metal in here, so it is a piece of metal with a metal ball. So nice setup. And with the center marked here, I know that my ball needed to be past the center mark, because you basically want that ball to be as far out as possible. So when this rudder turns, the ball is actually moving back towards the carbon rod there. But so that's our lineup with our rudder. Now this is going to be a bit of an interesting installation because we probably need access to this area, maybe to get our chute mechanism installed. So I have a feeling that we're going to be dealing with our chute mechanism here very quickly. So I think I've got a plan in place for that, but this gives you an idea of the rudder setup. So use the MKS carbon horn, put a washer here on this side for two reasons. Number one, to distribute the load. Number two, to make sure we had a little bit of space there in between our shaft for our ball and the actual servo body. So without that washer, it comes really close to rubbing. So that should be good. And when this goes in, we need to have a channel cut out in the cover plate for the servo arm to actually move side to side. So this is the cover plate here. That essentially goes over top and sits almost flush with that servo arm. So just like that. So I am going to get the rudder installed right now. It's not going to be permanent because we're also going to move on to the chute mechanism and get that all sorted out as well. So we're going to get this installed, take it out, and then we'll focus on the chute mechanism. So I have spent a couple days thinking about this chute mechanism, and I think I've got a plan laid out here. Now this drawing is not to scale, not to dimensions, not to anything like that. This is just a rough idea so you guys have an idea of what we're looking at. So here's our components that's going to make up our chute, and this is how they're laid out. So we've got an L bracket right there, an aluminum L bracket. This is one of the servo mounts, and that is going to attach to this piece right here, which is this hardwood piece right there, and that comes to here, gets cut off right there. That's this section. This little tab thing there is our gray receiver portion that the air cylinder gets mounted to, which is like that. And then we've got our plunger. That's not our plunger. Our plunger is going to be shaped something like this. So that is up, and the cutout on the bottom here is at the bottom of the device, and that's going to allow us to reach in here with a screwdriver and get this tightened up to the back wall right here. All of this is in an effort not to do any cutting on the chute receiver portion. I think this is a great way to do it. And then in the top portion here, we'll do a little cutout for the string for the chute, so right like that. And that string is ultimately going to come here and get mounted. There's a little channel I'll show you in a second, right by where the servo is, and that's going to get mounted up here on the servo plate. That is a great option as well too, because then the force of the chute doesn't require us to mount it to this assembly right here. This assembly is only for pushing. So that string is going to come along the top, and the channel I'm talking about is right there. There's a huge channel all along this cavity. It's going to come through there, and we can screw it back here on the side. Doesn't really matter where it goes, but that's going to be our little attachment point for the chute itself. That is going to work beautifully. So next thing we need to do is we need to cut our plunger out. Now I did cut a test plunger out of maple. I think this is like 1/2 inch maple. And the point of this was I wanted to see if this would fit inside the receiver portion and not move. So if we keep the plunger pivotable like this guy right here, I want to make sure that this wouldn't get stuck up and down like this, which it does. It completely moves freely in there, even though it's tight to the receiver portion. So solution to that is we're going to hard mount this to the shaft of the air cylinder. So it's going to have a washer. It's going to be, and it's not going to be this one. We're going to use a thinner piece because it doesn't need to be that big. And that's going to get screwed on to the actual plunger itself. Now, this system doesn't constantly have air. So when this plunger is compressed in, It just uses a one-way valve, so there's no air in the cylinder, there's no air closing it or anything like that. And when we activate the chute, there's a bunch of conditions we can have, so gear down, it shoots air out like this for about 6 seconds or something like that, and then it turns the air off. So it's not leaking, which is an important thing. So the reason I say that is if our plunger is hard mounted to the shaft of the air cylinder and it happens to put some sideways force on it or something like that, and it leaks a little bit out of here, really doesn't matter because the air is going to turn off shortly after activating that. So I'm going to take this and make a plunger system probably out of like 1/4-inch ply or something thinner anyways. All right, so we got everything basically mocked up here. First thing I did was cut my piece of wood down to size, screwed my angle bracket on. That's done with 3mm bolts and washers there. And got our mount for the air cylinder glued in place. Also added screws on both sides that go into the hardwood, so that's a double attachment point. And we've got a screw just kind of roughly holding the air cylinder in place right now. So last thing I have to do is my cutout on the bottom side here of the plate, and that's to allow us to get the L bracket screwed onto that wall of the chute area. All right, so we're mounting the system on the back wall. If the picture's funky, sorry about that. But that is where we're mounting it. So we can't go right in between those two bolts because that's where the receiver portion for the rudder is. So we also need to tighten those bolts up because they're very loose right now. So we're going to tighten those guys up, and then we're going to get that bracket screwed into place. All right, so I have pre-drilled one of these holes, and we are ready to install our chute mechanism. So we've got our air line hooked up. As I've mentioned, it's only one side of the cylinder which pushes it out. We just manually reset that. We've got a channel cut in the plunger, and there's a cover here that's going to cover up the whole. Flip that around. I marked it so we know which side was which. There's a cover there that's going to cover the hole so we don't get the chute caught on any of that stuff. So that is ready to install. Okay, so it's time to test the functionality of the chute mechanism, and oops. Once we do this, I'll show you guys exactly what I ended up doing. And yeah, let's go. Ready? 3, 2, 1, shoot. So what we ended up doing was using our original plunger piece to cover the hole. So I just made 2 countersinks in there. And so this is screwed into our other plate that you guys were seeing. And what this does is this takes up the extra space in this area. Now this is a very large chute area. The chute that we were demoing it with, this is one of the 2 Su-30 chutes. So it's a decent sized chute, appropriate for this size aircraft, so it should be realistic. This also is the plunger fully extended, so there's not much room left in there. Should open our magnet door just fine. That should work beautifully. All right, and we had some pipes show up today. That's 2 of the 3 that showed up. Give you a little sneak preview here of one of the upcoming projects for you channel fans. There you go. So the pipes come from JT Hobbies, Joe Tamez. He does pipes for all the Elite Aerosports aircraft, and we had our monster pipe show up today. I already unboxed it. Nothing exciting with the pipe unboxing, but let's take a look at the pipe. This thing is a monster to go with a monster turbine. All right, so here it is, exactly the specifications that we asked for. So absolutely huge pipe, just awesome. So this is going to be great for the Sweewind 400. So we're 120 millimeters inside diameter, basically exactly what we spec'd. You can see there the stock pipe inside diameter is 95 millimeters. Outside diameter, or sorry, inner diameter of new pipe is 25 millimeters or 1 inch bigger. Monster pipe. So unfortunately, with increasing the size of the pipe, I thought the afterburner would be close, but it's not even remotely close to fitting. Like the inside diameter of the afterburner is 120 millimeters. This is 130 on the outside, so yeah, it's too big. So we're going to skip the afterburner on this aircraft, and what we may do is run a line to the back, just so we've got that for future. If we want to put an afterburner in, at least it's there, and it's going to be silicone line, but we're going to just set this guy aside. And with our back end here progressing, we are going to get back and permanently install our rudder servo. Now with our door here on the chute mechanism, no rush for the door because the door really has no effect on anything we've done already. So we will be hinging the door on one side with the flat Robart hinges probably, and it's going to be fairly straightforward. It'll just open up like this, have a magnet holding it closed, so nothing overly crazy. So we'll do that over time as well. So what we'll probably do is take a shape of this so it matches nicely, round it off. We'll have to find a color match for the paint. So lots of steps to make the door, but that is something we can do over time. So now with the chute mechanism done, we're gonna get that rudder servo installed and then we can start running our stuff forward. We got our happy face, well, happy face, sad face, happy face done in our cover. So that is fit and works good. And just getting our rudder set up here. So it is a great system. I think this is wonderful. I do really like how they're going with the ball into a metal receiver. Some of the other Skymasters and other airplanes, you've got a rod that comes up and the rod is in a wood receiver and there's always a little bit of play. And I haven't plugged the servo in yet, but this guy is like super tight, just with the stock setup, nothing done with it, no lubricant added, nothing. So that is awesome. So I've left, none of this stuff is permanently done yet because we still have to make sure that this all works. So I've put an extension on our servo lead here. This is one of my shop extensions, so a really long one, like 15 feet long. So I can run that over to our radio system over there and we will turn this guy on and confirm that we're centered and we're happy with everything and the travel and all that. All right guys, so servo is on and that is a phenomenal system like I've already said. So I'm going to go through and show you guys exactly what I do here with these surfaces. And this one's kind of important because you've got a absolute max that servo can travel. And if you don't overcome that, it is going to cause mechanical damage. So first thing I've done here is gone in and added 5% sub trim just to get everything centered. And what we'll do now is we're going to go to our max positive, max negative. Now what that's going to do is that's going to set our max positive, max negative for that channel. But then what we want to do in the jetty here is we want to set our max positive limit. So that is the absolute limit that surface or channel or function can travel. And this is important because if you have any mixes or anything, it'll overdrive your first number and work into your second number. So if you have an absolute maximum that you need to work to, that's where you need to set it up. So we're going to go right rudder here, which is negative on our chart. So I'm just going to go all the way till that arm touches the fuselage, and that is about 92%. So what we'll do is come in here in the radio. That was our negative side, so we'll take this to 92%. So we want to get that number right there to be 92. If I had the camera down, this would be much quicker because I could just hold it, but there we go. So that's fine. So now we'll go the other way, and the reason this is offset is because of the sub trim. So we're going to go the other way and find out what our number is. So we're going on the positive side. So we're about there, about 67, 68%. Too much. There we go. So no buzzing with our stick to the right-hand side, left-hand side, sorry, and a little bit of buzzing on that side. There we go. So now our rudder is set up to its maximum limits. And what we'll do is we'll come down to our max positive limit and we'll drop that to 72. We'll go to our max negative limit, and that's 84. So now, no matter what mixes happen, that is not going to damage anything. So now our rudder is set up. So with that rudder setup, we're going to pull the rudder back off, vertical stab back off, and we are going to get our servo mounted now. We're going to switch out our leads, our extension leads, for our actual lead that's going to run all the way to the front. And this brings up a really good opportunity to share a tip time with you. And this tip time is brought to you by, ooh, that's not trusty, bent screwdriver. At the time of recording this, there is I think a few trusties left on the website. If you want to get a trusty bent screwdriver, once they're gone, they're gone. So I have shared this tip before, but I like to have some shop extensions here in the shop. So this is just a male-to-male extension. You can do female if you want, but male-to-male extension, really long ones. Like this is about 15 feet. I've got another one, I just keep them on my toolbox over there. I've got another one that's 20 feet long, one that's 8 feet long, and they work awesome. And if I need to plug in a servo like this, I just use one of these power box, the ones that make a female connector, the little plug-in things, so it basically plugs both of those guys together. And great way for scenarios like this, rather than taking your electronics, trying to find a suitable place on the airframe for it to stay. You know, it's just a pain in the butt. So I made these up years ago and they are very handy. Okay, so we're going to pull this vertical stab off now, undo our 2 bolts, and take this guy off. Quite easy to remove this thing as well. So we've got a 2.5 millimeter Allen key on the front. We've got a 4 millimeter Allen key on the big bolt on the back. And now we also need to worry about our light. There's a light lead that comes down in the rudder itself. So that needs to also be dealt with as well here. But that is taking off the rudder system. Super easy. So the light wire is already run right there. So what we need to do is we just need to make a hole in the suitable location right around this area. So we're going to get our cover done though first, get our servo screwed in and everything, and then we'll worry about that guy. So for a last step this evening, we've got our cover plate installed there, and we installed our light plug-in for the vertical stab. Now, this is pretty simple. If you just lay it on its side, get that hole lined up, easy peasy. So this is one of the extension cables that comes with the aircraft. And essentially what happens here is you plug this in. It's a single directional plug, but I did mark my plug black and red, and the excess here is just going to slip up inside this hole. So it's pretty important that you get that accurately measured, but you do have a fair bit of space there. So that is high solid in place, and we're letting that cure, and we'll come back to this tomorrow. And when we return tomorrow, our next goal is dealing with the mess from the back end. So we have to run a light wire for our afterburner, actually 2 light wires. So we're going to use our silicone wire, and we have to run all of this stuff forward neatly, out of the way of the pipe, and thoughtfully forward. All right, so it's the next day, and we are going to pop our rudder on here and confirm that we're all happy with everything. First thing I'm going to do, actually I'm not going to worry about it now. I was going to, when we put this together for permanent time, I'm going to put a little bit of lubricant inside the channel there, but for now we won't worry about that. We're just making sure everything works. So we'll get our light wire installed, and the primary thing here is you just want to confirm that this actually slips up inside the vertical stab and everything is lined up properly. I think we are good to go. There we go. That is awesome. Worked out perfect. So we can take our little tape off here that said the bolt is in the tray. So that, my friends, is the back tail surfaces complete. Now, I have been getting a bunch of emails, comments, questions about this beautiful plane in the background, the F-14 XXL. That will be starting soon. We're going to make some headway on the F-16. We do have a bunch of time before that needs to be done, so be patient. We're waiting on engines for that aircraft as well as the SU, so we will be finishing up the SU that's hiding over there as well. But we do have a deadline for some aircraft for the middle of March, and that needs to be done, or I guess the beginning part of March. Those need to be done. They take precedent over these types of aircraft. All right, and one little plug here at the end, a couple things. Don't forget to check out the lighter side of RC After Dark. The After Dark channel is where we do live streams here from the shop for about 2 hours every 2 weeks. It's tons of fun. We get to interact with you guys if you're on during the live stream. And the other thing I'll tell you about is channel membership. If you guys want to see the videos early, that's where you check it out, channel membership. It is a paid service, but you get to see the videos like a week, sometimes 2 weeks before they actually get uploaded to YouTube for everybody else to see. So definitely encourage you to check it out. There's some links down below. Next video, guys, we're going to continue on with the tail section, wiring, pipes, all that stuff moving forward. Today is Wednesday. 2 days from today, while we're recording this video, our tanks are going to show up from Joe, and we're going to be able to continue moving forward in this aircraft. So tons of awesome progress. Thanks guys for watching. We'll see you in the next video.